Hi everyone, welcome to srisai online training. So today in this session of Core Java demo session 3, we are going to discuss the following topics. So this will be a continuation topic, okay, about the last session what we discussed, features of Java programming, and then we will also discuss today specially advanced features of Java programming with technical examples. So coming to the small revision of the last session. So in the last session, we discussed about some features of Java programming. So we have many features of Java programming. In all those features, we have 12 notable features for education and training purpose. Of this 12 notable features, we have 6 basic features plus 6 advanced features. Right. So in the last session, we discussed about basic features of Java programming. So under that, we discussed Java is a simple programming language. Java is a secure programming language with respect to the memory. Java is portable programming language, okay, which can be executed on any machine with the help of JVM. Java is object-oriented programming language. So we have OOPS principles. So real life situations in the form of computer program is known as object-oriented programming. So under this we have discussed abstraction, encapsulation, inheritance, polymorphism, and for all these 4 features, basic 4 principles, we have separate chapters only. So we are going to discuss in-depth abstraction, encapsulation, inheritance, and polymorphism. So Java is robust. Robust means strong. So Java programs never hang, never break down. So this is because of exception handling and garbage collection. Java is multi-threading programming language. Okay, so which means that, okay, in Java, right, we can execute multiple logics parallelly in the same program. So multi-threading. So generally operating system performs multitasking, where operating system will be executing multiple different programs or applications parallelly. But if that multitasking is done in the same program, then it is called as multi-threading. So for multi-threading also we have a separate chapter. Right. So now coming to today's session topics, advanced features of Java programming. So coming to the next feature of Java programming, which is the advanced feature, and the 7th feature. Java is platform independent programming language. So what do you mean by platform? So platform means operating system. So for example, we have Windows operating system, we have Linux operating system, we have Mac operating system. Okay, so like this we have different operating systems. We also have Android operating system. Okay, so Java programs after compilation, they can be executed on any operating system without any changes to the logic, without any settings to the system to give the same output. Okay, so without logic changes, logic means coding changes, or without OS settings. So without logic changes, without operating system settings, we can execute the compiled Java code on any operating system. So how this is possible? So this is possible through JVM. So JVM stands for Java Virtual Machine. Okay. Now let us take one small example of traditional languages like C, C++. Okay. So basically, when we compile C, C++, okay, So those programs should be executed on the same operating system. Okay, so the compiled code of C++ does not work in other operating systems. Why? The reason here is because in C++, when you compile the program, we will get a machine code, and this machine code is a operating system dependable code. Right, so I'll put a small diagram here. For example, let us take C or C++ program. If you compile them on Windows, so when you compile them on Windows, right, so we'll get a Windows executable code, right? We'll get a Windows executable code, which is .obj code, right? So this .obj code is understood only by Windows operating system, and this code should be executed only on Windows. Similarly, when you compile C++ on Linux operating systems, so Linux means Red Hat operating system, CentOS, SUSE, Debian, we have different types of Ubuntu, etc. So there you will get .o code. So this code is understood only by Linux operating system, and such code should be executed or run on the same operating system. So these are platform dependent programming languages. Okay, so what is this machine code? So machine code means OS understandable code. So such code is understood only by that particular operating system. So for example, .obj code is understood only by Windows operating system. .o code in Linux is understood only by Linux operating system. But what happens in Java? Okay, so basically in Java, when we compile the program, we will not get the machine code directly. We will get the byte code, and that byte code is .class file. Okay, so JVM understands this byte code and makes this byte code independent of operating system. Okay, so for example, if you see the diagram, so Java programs are written with .java as extension, and when we compile them, so compile them on any OS, Windows OS, Linux OS, or any OS, we will get the .class file. So technically this is called as bytecode, and this bytecode is understood by JVM only. Okay, so with the help of JVM, we can take this bytecode from one operating system to another operating system and run on any operating system with the help of JVM to get the output. So that's why we can use .class file. Okay, so .class file runs. Okay, .class files runs on any OS, and this is with the help of JVM. It runs on any operating system with the help of JVM. Okay, right. So basically, bytecode is JVM understandable code. So such code is specially developed by Sun Microsystems for making Java programs run on any operating system with the help of JVM. Okay, so here JVM is responsible for platform independency. So basically, JVM is separate for every operating system and makes our Java programs independent of operating system. Okay, and hence we call JVM as intelligent piece of software. Okay, so once again I'll repeat it. JVM is platform dependent. It is separate for every operating system and makes our Java bytecode independent of operating system. platform independency. Okay, right, the final note point goes like this one. So basically in traditional languages like C++, when we compile the program, we will get the machine code directly, and this machine code executes on the same machine without any portability. Hence they are called as platform dependent languages. Whereas in platform independent languages, when we compile, we'll get the bytecode. Okay, example Java, and this bytecode is understood only by JVM. So such code can be executed on any operating system, provided on that JVM should be installed. Okay, so JVM is available for all OS in electronic devices. It is available for all operating systems in electronic devices. So this is what is all about platform independency. Okay, so platform independency means write once, run anywhere. Okay, so write once, comma, compile and run any operating system. So write once, run anywhere, any operating system is all about platform independency in Java programming. So coming to the next advanced feature of Java programming, architecture neutral programming language. Okay, so what do you mean by architecture? So why Java is a architecture neutral programming language? So here architecture means system hardware. Okay, architecture means system hardware. So for example, let us take a computer, personal computer. So in personal computer we have Intel motherboards, Intel processors, or we have something like gigabyte processors. Next, if you go for a mobile, in mobile you have Snapdragon processors or MediaTek processors. Okay, next, if you go for embedded systems, in embedded systems we have ARM microcontrollers. Okay, so for personal computers you have a separate hardware. For mobile systems you will have a separate hardware. So hardware indicates your processor here. So system hardware means mainly your processor. Okay, right. And then when you go for embedded systems, single purpose electronic devices. Okay, right, so single purpose electronic devices, right? Yes, so gigabyte, or you can also say this as AMD processors on gigabyte motherboard, exactly. Okay, so on embedded systems we have ARM processors, ARM architecture with microcontrollers. Okay, so different electronic devices have different hardware. So what do you mean by neutral? So neutral means Java programs executes on any hardware without any changes to give the same neutral output. So same neutral output means same colors, same graphics, same speed, or same performance. Okay, same colors, same graphics, same speed, same performance. So that is what is the speciality of architecture neutral. Now how this is possible? Again, this is possible through JVM. So when we install the Java software, JVM is also installed along with that. Okay, so JVM is called as intelligent piece of software. Okay, let us take one small example. For example, let us say that you have downloaded a movie from internet. You want to play that on the laptop or personal computer. So they will play without any issues. Okay, but sometimes when we play the same movie on the television, we'll get some abnormality. Okay, so when we play the same movie on mobile or something like tablets, we get some abnormality. Reason, the movie downloaded file from the internet is compatible with PC or laptop perfectly for Intel architecture or AMD architecture, whereas mobiles, TVs and tablets, they have different system architecture or system hardware or system processor, so they will not play properly. Okay, so that is what is the abnormality which happens with other hardwares. Okay, so abnormality means they will lag or resolution will change. Okay, they will lag or the resolution of the movie will change. So why this is happening? This is because of different hardware available in different machines. Now coming to the Java programs. Okay, so Java programs means .java file. When you compile them, we'll get the .class file. So technically this .class file is called as bytecode. Okay, right. So now coming to the Java programs. So JVM makes our Java program neutral for execution on any hardware. Personal computer hardware, laptop hardware, okay, TV hardware, mobile hardware or tablet hardware. Any hardware. Okay, it is made neutral only because of JVM. Okay, so it's very simple here. So .java files, when we compile them, we'll get the .class file or the bytecode. Now this bytecode can run on personal computer or laptop computer or mobile or TV, smart TVs or tablets, etc. And this is possible only because of JVM. So Java Virtual Machine. So same performance, same speed. You will get the same output. Okay, so this is what is called as architecture neutral. So technical points goes like this. JVM software is separate for every hardware and makes our Java programs neutral for execution on any hardware. So same like platform independency, architecture neutral is achieved for Java programs through JVM. So that's why JVM is a intelligent piece of software. So now coming to the next feature, Java is compiled language as well as Java is interpreted language. So both these are technical words, compiled language as well as interpreted language. So what does it mean? Let us try to understand this in detail. So basically we write Java programs with .java as extension. So after compiling the Java program, we'll get the bytecode. And the extension for bytecode is .class file. Okay, now who will do this? So this is done by Java compiler. So when we install Java software, Java compiler is also installed in our system. So compilation means converting the Java program into bytecode is known as compilation. Okay, so .java file, compile, we will get the dot class file, which is technically known as bytecode. Okay, now this bytecode is platform independent as well as it is architecture neutral. How? Because of JVM and Java interpretation process. So because of interpretation process. Okay, and this interpretation process is done by JVM. So how this is done by JVM? Let us try to understand with small example. So first we'll take C++. So basically when we compile C++ programs, we'll directly get the machine code. Okay, we'll directly get the machine code in C++, which is OS understandable code. Okay, whereas in Java, we'll get the bytecode, which is JVM understandable code. Okay, so hence C++ programs are platform dependent and system architecture dependent. Okay, whereas in Java, okay, dot class file is machine understandable. It is again converted into machine understandable code through the process of interpretation, and such machine code is independent of operating system. Okay, it is dependent on that particular operating system and hardware, and it is executed with the help of JVM to give the required output. So it's very simple here. .java file compile, we'll get the dot class file, which is bytecode. Now this bytecode we have to run. So when you run, you will get the output. So what happens when you run the bytecode? Okay, so internally this things happens. So dot class file, when we run, internally two things happens. So first, dot class file is converted into machine code with Java interpreter. Okay, so Java interpretation, right? So Java interpretation, it will convert your dot class file into machine code. So this machine code is not visible to us. It is available only in the program memory, and after executing the machine code, it is deleted from the memory. Next, this machine code is executed line by line to give the output. Okay, exactly. So technically, machine code is OS understandable code or binary code. It is OS understandable code or binary code. So when we run the program, internally two things happens. Interpretation will happen, you will get the machine code, and that machine code is executed line by line to give the required output. So here technically, okay, interpretation plus execution is equals to running the Java program, and it is done internally by JVM. So that's why JVM is responsible for platform independency and architecture neutral. So here we will compile the Java program, we will get the bytecode. When you run the bytecode, you will get the output. So internally this bytecode is interpreted, again converted to machine understandable code, Windows understandable code, Linux understandable code, etc. And then it is executed with the help of operating system to give the required output. So this is what happens with JVM. So one small technical point here. So interpretation process is a JVM work, and it is responsible for making Java platform independent, architecture neutral, and portable language. And basically this execution of machine code is done by JVM using a small piece of software known as execution engine. Okay, right. So one more point also. So interpretation process is done by Java interpreter. Okay, Java interpreter, and execution process is done by Java execution engine. So Java interpreter and Java execution engine are inbuilt with JVM. Okay, so interpreter plus execution engine are inbuilt with JVM. So they are inbuilt with JVM. So that is why JVM is a intelligent piece of software. So this is how Java is both compiled language as well as interpreted programming language. Compile as well as interpret. So coming to the next feature, Java is high performance programming language. So how Java is high performance programming language? Okay, so Java programs, they gets executed any machine, any operating system, any hardware, very quick, very fast, and they are very responsive. And this is possible through garbage collection feature. So what is this garbage collection? So garbage collection is a small piece of software. It is inbuilt with JVM. So when our program is getting executed, automatically in the background, unnecessary data, unnecessary objects will be deleted. So what happens? Automatically the program space increases in the RAM. So when program space increases, performance of the program increases. So ultimately performance of the Java program increases, and Java programs are never hanging programs. They will never hang your system. So garbage collection is an automatic process which is available with the JVM, and these are executed 24/7, 365 days on any server machines. So server machines means generally internet websites, because internet websites, they should run 24/7, 365 days. And herely also indirectly JVM is responsible for high performance and robustness of Java, because in JVM only we have garbage collection, which is a automatic program or automatic algorithm. So coming to the 11th feature or the 5th advanced feature, distributed programming language. So what do you mean by distributed? So distributed means group of computers interconnected with each other using some network. For example, local area network, wide area network, metropolitan area network, or internet. What is the purpose of internet? Communication. Okay, so this is what we call as distributed. So multiple systems are connected together using internet. For example, system 1 is connected with internet. Similarly, system 2 is also connected with internet. Similarly, system 3, so on. So all these systems are connected to internet. So in this internet, we can develop internet web applications, which are technically known as distributed applications. Right. So now coming to the basic definition. So Java programs can be executed on two or more systems interconnected with each other using some network. For example, chatting application, email application, file sharing application, internet web applications, e-commerce application like Flipkart, Amazon, etc. And technically these are known as distributing. Okay, this concept is known as distributed programming. And in Java, distributed programming is achieved through JDBC, network programming, servlets, and JSPs. So these concepts we are going to discuss mainly in advanced Java. These are advanced Java concepts. Java database connectivity, Java servlets, JSPs, etc. So using Java, distributed programming is possible, which is network-based applications. So coming to the last notable feature, one of the advanced feature of Java programming, dynamic programming language. So what do you mean by dynamic? Dynamic means something. Something means data which changes in our application or Java program with respect to time, with respect to location, with respect to user. For example, what do you mean by dynamic? Okay, so dynamic data means change with respect to three things: time, location, or users. So if our application dynamic data has to be done, it has to change with respect to time, with respect to location, with respect to user. So these applications are called as dynamic applications. So let us take, for example, weather report. So weather report will be changing from location to location. Okay. Cricket scores, they will be changing from time to time. News updates, they will changing from time to time, location to location. So stock market updates, basically they will change from time to time, daily basis. Email updates, so email application or social networking application. Okay, so in email and social networking application, data or information will be changing from user to user. So every user will have their own emails, own post, own comments, own data in social networking applications. So these are called as dynamic applications. Okay, so using Java we can develop dynamic applications, especially on internet or web, and these applications are developed with three-tier architecture. So in three-tier architecture we'll have client, server, database. So client means your browser. Okay, client means browser. Server means Java. We are going to use something like Java related Tomcat server or Glassfish server. Database, so database means you can use Oracle or MySQL. Okay, so browser, Tomcat server or Glassfish server is the server, and then database is the Oracle or MySQL. Okay, right? So basically, how to develop a three-tier architecture dynamic web applications? Again, it is possible through servlets, JSPs, JDBC, Spring, and Hibernate. Okay, and this helps us to develop dynamic web applications. Client, which is a browser, server, Tomcat server or Glassfish server. Database, we can use Oracle or MySQL. So this is how dynamic applications can be developed using Java. Right, so that is what is all about today's session in Core Java. We have discussed features of Java programming and some advanced features of Java programming. So under advanced features of Java programming, we started with platform independent programming language, architecture neutral programming language. So both compiled as well as interpreted programming language. Next, we have also seen high performance programming language, distributed programming language, as well as dynamic programming language. Okay, so these are some advanced features of Java programming language. So because of these features only, most of the people in IT industry, they prefer to develop computer applications or any other electronic devices and its applications using Java programming language. Right. So thank you guys for watching and listening to this session. Have a nice day.